All right, we're moving on to Module 6, which will be our expressions and equations module. We're going to start off with adding and subtracting expressions. The good news is we can use our properties of addition along with the distributive property to add and subtract algebraic expressions. Let's take a look at an example. In this example, it tells us that Jill and Kyle get paid per project. They get paid a little bit differently. It tells us Jill is paid a project fee of $25. So no matter how long she works, she gets a flat fee just for being hired of $25 up front, plus $10 per hour. Kyle is paid a project fee of $18 plus $14 per hour. So these two people get paid a little bit differently. Wants us to write an expression to represent how much a company will pay to hire both to work the same number of hours on a project. So if I'm using my 3 reads method, which I should because it's a word problem, that's my first read. That's my topic. Well, I know the topic is it's a problem talking about two people getting hired to do a job together, but they get paid differently. My second read through, I know it's talking about writing an expression to represent how much a company will pay to hire both. So my third read through, I identify my important piece of information. I know Jill is paid $25 plus $10 per hour. And I know Kyle is paid $18 plus 14 per hour. So they're two different things, but they're getting hired to work the same job for the same number of hours together. So I'm going to start by making expressions for each person before I push them together into a team. I know since Jill gets paid $25 plus 10 per hour, I can write my expression for Jill as 25 plus 10h. Notice here they're letting h represent the number of hours. H, hours. Easy to remember. When you're making your own expressions, you can use whatever letter you want for your variable, but using something that helps remind you what it's representing is usually a good idea, which is why here h is for hours. So Joe gets paid $25 plus $10 per hour. Kyle is the same way. He gets paid $18 plus $14 per hour. So we have each person's expression. They're a little bit different, but they're set up the same way. Now, if we're going to find out how much the company will pay to hire both, we need to push those two expressions together. So you can see here that they have combined Jill's expression and Kyle's expression. They're in one thing. Now, since everything is addition, we do have that wonderful commutative property, which tells us we can move things around as needed. So you can see that what they've done is that they rearrange things so that Jill's information is not just with Jill's information and Kyle's isn't with Kyle's, but rather they've put it so that our constants and our variables are grouped together. Makes it a lot easier to combine things. So that's what our next step is. We're going to combine things. We can start by combining our constants. 25 plus 18 gives us 43. And then we can combine our variables. 10 plus 14 gives us 24. So now we have a simplified expression, something that's a lot easier to use. It's a lot easier for the company to look at this one expression and say, oh, okay, we know that when we hire these two people, we're going to be paying $43 right out the gate in fees. And then we're also going to be paying $24 per hour for however many hours they work. Makes it a lot easier for a company to figure out how much they're going to pay. If they know, oh, well, this will probably take about 10 hours, they can now estimate about how much they're going to have to pay to hire these two people to work together. Which leads us nicely into our important question here. What can we read directly from the expression 43 plus 24h that we cannot read directly from the equivalent expression 25 plus 10h plus 18 plus 14h? Well, it goes back to what our goal was. Our question in the last problem asked us, how much is the company going to pay? The simplified one makes it a lot easier for the company to see how much they're going to pay. It makes it very simple for them to tell that they're going to be paying $43 in fees and $24 per hour. That's the idea. So let's try it in an example. We've got two problems here, so solving them shouldn't be anything too horribly difficult. Looking at number 2, I can see here that I've got a variable and a variable. I've got a constant and a constant. The only slight issue I might have is that I've got a subtraction here. But we know how to handle subtraction. We know that when it comes to subtraction, we can use keep, change, change. So I can take this subtraction and turn it into addition, so long as I turn this 4.5 into a negative 4.5. So now we can combine things. I know if I've got 3 of something and 7 of something, I've really got 10 of those somethings. And if I've got a half of something and a negative 4.5 of something, since they're different signs, I can subtract 4.5 minus 1/2 leaves me with 4. And since this had more, we're going to keep its sign. So 10x plus negative 4. You can also write this as 10x minus 4. It's still the same thing. Let's move on to number 3. Same thing here. Notice we've got variable, variable, and constant, constant. We do have a little bit more in terms of subtraction, so I'm going to start by rewriting this first part of the expression. I know negative 0.25 is just negative 0.25x. But since subtraction, I can keep, I can change, and I can change. So I rewrote that first part. Now, the second part can be a little tricky. Since we're subtracting and parentheses, what it's saying is we're subtracting all of this. We're subtracting each of these things. So what this is really saying is that we're subtracting 1.5x and we're subtracting 1.4. So I can rewrite that. I can keep, change, change. I'm going to have a negative 1.5x and a negative 1.4. Because remember, this was minus 1.5x and minus 1.4, because this subtraction here is applying to this and it's applying to this. So when I rewrite it, I've still got the same things. I've got variable and variable. I've got constant and constant. So now I can start combining. I know if I've got negative 0.25 of something and negative 1.5 of something, they're the same sign. So I'm going to add them together and keep the sign for negative, sorry about that, for negative 1.75x. And same thing with my negative 3 and my negative 1.4, same signs. So I can add them and keep the sign. Same as the last one, we could also write this as negative 1.75x minus 4.4. Same thing, whatever you come up with. All right, that should be it for this one. I will see you in the next section.